I hope you've already watched the Introduction to LeChatelier's Principle video because I think this video is a good follow-up to it. And so please watch the other one first before going through this one. This video is going to go into more detail on LeChatelier's principle and shifting of equilibrium. I've got 4 pictures here I want to show you and explain the shift in equilibrium, those as a stressor is being added to the system. So let's remember that LeChatelier's principle, okay? LeChatelier's principle is the principle that when a stressor is added or removed from an equilibrium system, that the system will shift itself in a way to relieve that stress, to relieve that disturbance, so to say. Now, one of the stressors that can happen is a change in volume, okay? A change in volume of the system, especially when we have a reaction system that involves gases. In the previous video, I had this equilibrium, I believe, present with the nitrogen and hydrogen gas and ammonia. It might have been there, I'm trying to remember. Okay, when this reaction happens and you produce the ammonia, notice that we start out with 4 moles of gas as reactants, and we produce 2 moles of gas. Okay. Now, gases are constantly moving, and their velocity, their kinetic energy is dependent upon temperature. So, as we change the volume of the piston cylinder here, by decreasing the volume, we're giving it a smaller space to occupy. Okay? With a smaller space to occupy, there's going to be an increase in collisions between those gas molecules. Increase in collisions result in an increase in pressure, because remember that pressure is equal to force divided by area. Is a measurement of the force of collisions over a particular area of space. So as we decrease the volume, we're going to increase the pressure. Now, how is this reaction going to reduce that stress? Okay, how is it going to get back into equilibrium? Well, if we're seeing an increase in pressure because of that decrease in volume, what we're asking is, how are you going to decrease that pressure? Well, decrease the pressure would be have less collisions. Okay, fewer collisions, lower pressure. How do we get fewer collisions? We have fewer gas molecules. We have fewer gas moles. So this reaction system would shift itself towards the side with fewer moles of gas. Fewer moles of gas would give you fewer collisions, which would counteract that increase in pressure. Okay, so it would go to the side of the reaction, to the right side here, the product side, where there's only 2 moles of gas, rather than the left side where there are 4 moles of gas. See, fewer moles of gas would give you fewer collisions, which counteracts that increase in pressure. So let's look at that same style of stressor, only let's look at it in the opposite direction. Let's increase the volume. Okay, so let's reopen this piston. Let's expand the cylinder here by raising this piston. It gives a greater volume. A greater volume means the gas molecules can spread out, get further away from each other. They get further away from each other, there's fewer collisions. Fewer collisions, decrease in pressure, lower pressure. So now what does the system do to counteract that decrease in pressure? It can shift to the side with more moles of gas because greater volume, more space. Let's go to the side with more gas molecules. More gas molecules because we have a larger volume, lower pressure. Okay, so we go to the side with more moles of gas. Okay, so after these two pictures, if you see a decrease in volume, which will increase pressure, the result, what happens? This will cause a shift to fewer gas moles. Okay, there'll be less gas. Okay, if we do the opposite, we increase the volume, which is going to decrease the pressure. Those are inversely proportional. Then we're going to see a shift in the equilibrium to the greater gas moles. Okay, the greater number of gas moles. Okay, this is what LeChatelier's principle helps us see, is these equilibrium states are being disturbed by various stressors. How does the reaction system shift? Does it go to the left? Does it go to the right? Would that stressor increase the product's concentration or decrease the product's concentration? What will happen? If so happen that the moles of gas were equal, if these were 2 moles to 2 moles rather than 4 to 2, then pressure and volume changes wouldn't have an influence. They wouldn't increase or decrease any, or shift anything. Okay? All right, let's take a look at another picture here of a reaction system in equilibrium. Okay, here we've got some N2O4, so dinitrogen tetroxide gas. And we've got some NO2 gas. There we go. All right, so here's our system. Okay. Let's disturb the equilibrium by adding more NO2. Notice over here in our side picture, we're going to open up the vessel, drop in some more NO2 molecules. Okay, now we've got an overabundance of NO2s. These are gas molecules, so they're going to be flying around, colliding into each other. What is going to happen? The NO2s that you just dumped in, now when they collide with each other, they can stick together, bond together, and form the N2O4. Okay, so if you drop in those NO2s, they're going to collide and could produce more product. Okay, this is no different than, let's say you're in the kitchen and you have a recipe. If you double the ingredients, the quantity of ingredients, then shouldn't you get double the final product? If your recipe calls for 2 dozen of cookies to be yielded, if you double the quantity of ingredients, you should be able to produce 4 dozen of cookies. Well, here you add in more NO2 gas molecules, you increase that concentration, they're more likely now to run into each other, to collide, and to have successful collisions, which would bond together and produce you more N2O4. So the system would shift to the left towards the N2O4. And one final picture to look at another equilibrium shift. Same system, the N2O4 and the NO2. All right, let's do the opposite. Let's add in some more of the N2O4. We add in those. What can then happen? The equilibrium is disturbed. Those N2O4 can now split apart. They're more prevalent, more abundant. We got to get back to that equilibrium ratio. They're going to split. Okay, they can break apart and lead us to more NO2 molecules. Okay, so when you increase or you add concentration of one substance, when you add concentration, you're going to shift away from the added side over to the other side. Okay, we noticed that when we added N2O4, our equilibrium shifts to the right, to the NO2, away. You notice in our previous example, when we added NO2, we shifted away, we shifted to the left, you see, to the N2O4. Okay, so I hope this video just helps you see visually with these pictures how LeChatelier's principle describes and gives you an explanation of shifting an equilibrium in a reaction system.